week 10 folder, you'll find a couple of items in there, and I'll show you. One of them is a video, and I've had some students say this was a very helpful if they tried to do this subnet calculations, that this video explained it probably better than I did by far. So I encourage you to spend the 5 minutes, 40 seconds on that. I can't play it and record at the same time, so I'll leave that to you. The other one I have listed down here is a calculator. There are a lot of them out there. This is just one I've used before. In fact, there's all different kinds of things at Calculator.net if you're wanting a mortgage or all kinds of things in there. In this case, we can use it as a IPv4, and they also have an IPv6 subnet calculator handy for us. So network class. Here we have our subnet, and you notice that that's a pull down, and so we can see those, in this case, CIDR notations of every one of those subnet masks that we can use. So this is a handy way to do that. So if I wanted to divide this into a /30, my IP address started here, we thought. I can calculate, and now it breaks down those. So here are all these possible ranges. So we have a network address of 7.0 with a range of 7.1 to 7.2. So it lists all of those down there, and we'll calculate that out for you. I tend to do stuff by hand really quickly, and then I'll go to somewhere here and make sure that I've not completely lost my mind and double check. Because when I'm planning, sometimes I need to think about how those addressing schemes are going to work. But then I can use this, grab that list, and then I know what is in each possible range. So in this case, we've created 64 possible networks, but they only have a range of 2 IP addresses. So that might be useful when we're setting up some network equipment or something else. But so this is a handy tool, and there's lots of them out there. So unless you're taking this certification test, in which case you have to do those by hand at the test, there's a lot of tools out there to help you on those. So I put those 2 items in the bottom of week 10, just so you can see those. Go thing. So I just wanted to go through that really quickly again because we rushed through at the end a little bit. So a typical switch, everything connects to it in one block. That idea of that VLAN, we separate them into virtual LANs. They're still connected to the same physical switch, but they're connected to 2 separate networks. And again, this is another example of a VLAN style switch that we can set up. This one's a little bigger. This one's a 48 port switch, which is kind of the typical size in our cabinets. We'll run 48 port switches, and then we'll have multiples of these in our network. Now, this shows them in blocks. You do not have to do it that way. There is some logic if you have extra port switches to do that, to make your life easier when you're trying to trace out and figure out what's going on in the world. But you certainly do not have to do that. You could have 12 different VLANs and have them on one on each port and do whatever scheme you want. When you go to manage it, then it gets a little more complicated because you have to figure out which port is in there. So what it really does, what VLANs really do, is add a tag in there that says, I'm sending this traffic and it's destined only for a particular network, whatever tag number I have in there. It typically strips that out at your destination, so you aren't going to see this. Most of the time you have no way to know what VLAN you're on. And that's actually a security feature to keep you from being able to VLAN hop or do anything really odd. So there are ways to break VLANs, but for the most part, they're a really secure technology. So by putting that on that outside edge, so in this case, you could have 3 switches. Each of them have multiple VLANs. And only those devices on VLAN 1 can talk to each other. VLAN 2 can talk to anybody in VLAN 2, and VLAN 3 can talk to anybody. That said, I can configure that router then to allow communications from those different VLANs, and I can limit what gets communicated. So maybe my VLAN 3 is my wireless. My wireless, I only want web traffic on, port 80 traffic, and I can restrict it. I can further do some other restrictions, but I could keep that traffic on the wireless, so maybe that's the guest wireless, to only specific locations. I could restrict the access on VLAN 2 to maybe all they can access are printers on VLAN 1. They can't do anything else. Or maybe we have some shared folders and we can restrict access to just that. So VLANs really give us a lot of flexibility in configuring our network, but we have to spend that time up front to figure out how we need to do it. So I prefer this method versus doing all kinds of weird subnets and odd IP addresses and then having to use a router to put them back together. I still need a router in this in a lot of cases, but if I'm doing a managed switch that will do VLANs, a lot of times they have enough capability that I can actually do the routing then, at least for the VLANs, in the switches. So they're really a great technology, and if you're going to break up a network, that's probably my preferred method to do that. So there's other ways we can do it. We could physically run separate switches for VLAN 1, 2, and 3. So if I'm looking for ultimate security and I really want them separated physically, I could do that and have multiple LANs that are physically separate. So high security areas, sometimes we do that. When I've worked with some police departments and sheriff's departments or police agencies, we do that. They're still paranoid a little bit about VLANs, at least on the local level, and trying to explain it to them is a little tough. And sometimes for ultimate security, we do put them off on their own separate ports. So your book talks a lot about something called trunk ports or an access point. So trunk ports you can think of as a way we link switches, might be the easiest way to think about that. So if I'm going to make a connection between switches, then I have to construct what's called a trunk. In other words, all those VLANs will pass through that trunk. I can control which VLANs go through that trunk. So it's my connection in or out of that switch with those particular items. So it might make more sense to think of it this way, and maybe looking at it from a screenshot. So here I have VLANs 1, 2, and I don't show 3 in here. I don't have any ports configured for 3, but I have to support that trunk feature, so I have to be able to pass them through there. And so I do that, in this case, on a single traffic port here. So that's what uplinks, in this case, back to the network. So it's a way that we consolidate it. So maybe it makes more sense. The other way to look at it is a sheet like this. So here we have those trunk lines. So in other words, the connections between switches, and I've got them configured to take specific types of traffic. So that some items may die in that switch. They don't go past that switch. If it doesn't have a home inside that switch, it's gone. So if I don't have those trunk lines configured from switch to switch, VLAN traffic dies. In other words, it has nowhere to go if it's trying to reach somewhere else. So those trunks can carry the traffic for any of the ports, untagged, tagged ports, however we want to set that up. So we can combine them, this idea. So now we're going to put subnets. So VLAN 1 is in subnet 1, VLAN 2, subnet 2, VLAN 3, subnet 3. So not only are we broken up by IP address, we're broken up by that VLAN. And so sometimes this is the way we approach it also. So I weirdly typically will grab VLANs and I'll put completely different IP addresses. So they're technically not reachable by each other anyway. But the subnets just allow us to break that up. So if I've used my subnet calculator and I've broken up my IP address into 4, 6, or 8 ranges, then I can do that for each VLAN. So again, there's a lot of planning involved before we get to that part. So when we get to those trunk lines and we get to that types of VLANs, a couple of different ones that we see right now. So if are a default or a unconfigured, so a switch that is not managed typically will pass default VLAN tags. So even though it's not configured to pass them, it'll typically send them through. We also have what are called the native VLANs. So any untagged frames and untagged ports will pass traffic. So again, that's a managed switch. Maybe we haven't configured VLANs yet. It's still able to pass that. And then we can break it up. And one of the reasons we also break it up is that idea of quality of service. So we can have data or voice, or in some cases we even have video VLANs. Those typically will assign quality of service. In other words, we're trying to get priority for voice traffic, which is one of our bigger ones now, because you notice it in voice a lot. If you have a couple of dropouts, your voice call is less and you immediately complain. And we know that our businesses thrive on voice calls. So if we have our voice going over our network, then we will probably prioritize that traffic. If your email takes a couple of extra seconds to send, it's on that data network, it's probably not as big an issue. Video, though, we have to think about a little bit, because the audio portion of video is pretty critical. The video, though, if we lose a couple of little dots in a picture, are we going to notice it? Probably not quite as quickly. On the other hand, if we're the content creator and we're pushing up a big data stream, we might want to prioritize that. So we do have to look at our types of traffic we're supporting and what we've got going on. There are other types of VLANs that we can use. The management VLAN tends to be low priority, so we can set that up. If it takes a minute or two for the switch to get the data and reconfigure, probably not a big issue. I don't want to interrupt my voice calls based on I'm sending out a management request to change something. So we have some VLANs. You'll see here at our college, as an example, or a lot of them, we can set them up for things like GoBlue. So GoBlue is on a VLAN on our college. So if you log into the wireless, it's on a wireless VLAN. There's also some secure wireless VLANs that are set up. If you're plugged into a secure port on campus, you can be on a different connection. You could be on the administrative LAN, or you could be on the faculty LAN, or however they've got it broken up. We can see that. So we set them up, and it's via the switch. So one of the advantages to having a set of switches from the same provider is that in some cases there is a software piece that you can get that's kind of an umbrella. So HP/Aruba has some software you can buy that will allow you to manage all of your switches at one time versus having to go to each switch individually. And we're doing things like setting up VLANs. That's a really big advantage. So in some cases, we end up setting them, and you end up setting them by command line. So this is a Cisco switch, the shot they show you here. And in this case, they have a whole stack of VLANs, and they're showing which ones are active on which port. And this is a show VLAN command that's equivalent on the HP. There's something very similar. So some of these you have to do, unless you have that overreaching management software, you're going to do it this command line environment. And if you're not doing it every day, it's hard to remember all the commands, quite honestly. It's not something I do every day. Sometimes I have to look it up, going, oh crap, I can't remember how to do this string. But we will set them up this way. I like the software you can see with a lot of them where you can do this page and it looks very easy. The downside to that is I can run scripts. If I'm running something like the command line, I can pre-configure a script, have it ahead of time, and upload it and get that switch configured the way I want very quickly. So there's pluses and minuses to both ways of configuration of a switch. So what do we do when things go wrong? And sometimes we do have issues. We're putting out a lot of data. We're trying to keep track of it. Ah, crap. We screwed up and set up the switch wrong. So we set up the wrong type of access port. So we configured it as a trunk, not as an access point. Happens. Typically, we'll set up a standard. So if we have switches that are 48 ports and they have 4 uplink ports, those will be the only things configured as uplink. So we want to be consistent from switch to switch. If you have a big environment with hundreds and hundreds of switches, it can be really confusing. You want to make some common setup configurations. If you have the wrong VLAN assignment, again, somebody plugs into the wrong connection, suddenly you're on the wrong VLAN and you're getting the wrong information. So I got to see that one firsthand accidentally this week. The courthouse in Nemaha County, I do a little bit of assistance with some technical issues for them and kind of serve as kind of an intermediary between they and the state, because the state actually maintains a lot of the network for the courthouse. So I got a call that they had decided to repaint an office, and it just unplugged everything and then just plugged it back in and nothing was working right. Well, there's a problem. The state decides that they are going to separate things like printers onto the separate VLAN than the computers, and the computers, there's a couple of different VLANs for them. Well, nobody knew, nobody marked anything, nobody took a check, nobody knew anything about where anything was plugged in. So in typical state fashion, I emailed them to get a ticket. Well, 3 days later, I'm going to get a response because they're busy and overworked. So what we had to do, because we can't see what VLANs they are, and I can't access their switch because it's locked down by the state, we had to resort to the old method of try it one at a time until we figured out which one was going to give you the right IP address and the right VLAN. And it was painful. All it would have taken was them to, use a little flag and mark where things are at. But it happens a lot of times. Offices, people will go, well, I'm going to move my computer, and I plug into a different data port. That data port isn't set up for the VLAN that they're supposed to be on. And in fact, in a really secure setting, they're going to plug it in and have nothing, because we're going to have unconnected or shut off via software those open ports, so you don't have people doing bad things. It happens a lot. It can happen on purpose when we set up things and we have something wrong or we transpose a number. It happened here in this building. We had a network tech that worked for the IT department decide to clean up the cabinet. When he did that and made really nice, neat little short cables, he didn't pay attention to what was in and what was set up for previous VLANs, and it took Delin and the guys probably a while to get that fixed. So it can be rough. If you don't have it documented, it can be a little rough. That was the other piece that I ran into with dealing with the state network. It wasn't well documented. Yes, they could tell me what switch port it is, but through an old building running around, I had no clue. And so the quickest method, weirdly, since there were only, I think, 8 or 9 connections there, was we just did them one at a time until I could figure out which one it is. So each success, and I probably still had some that weren't right, but we managed to get the network up and working. So one thing that can happen, and we have to be a little bit careful of, is something called VLAN hopping. So remember I said you need all this documentation. Well, that's great. Don't put it out on the public internet for people, because one of the things that we can do is we can try to inject that payload so it looks like we're actually coming from a different VLAN. Well, I need to know some information about that VLAN first. So this is a case where, yes, you need to have everything documented, but make it a little bit harder to get to. So VLAN hopping can occur. Typically, you're going to notice something weird going on your network. So a lot of intrusion detection software is going to notice this pretty quickly. So I'm going to guess Peru's not at a big issue for this on our VLANs, but anytime you have a connection, you're not sure what it is, that leads to that suspicion of, is somebody trying to do something? I'm on my computer, and all of a sudden I've got a lot of things running very slowly. Is this attack I've got going to try to hop VLANs? So we typically have people on restricted networks. So are there networks like the administration side that may have data they want? So a couple of ways we can do it or mitigate that a little bit. Let me go backwards a second. I think I jumped 2 there. So a couple of really semi-easy ways they can do it. In other words, we're modifying that frame, and that's how we can do it. We can also try to get to a switch, and we can change our switch type. So the switch we're connected to, if we don't secure that switch, and I change the port that I'm on so it looks like I'm a trunk, that allows me to feed VLAN traffic in there and pass through pretty easily. So that switch spoofing is probably the easier of the two, simply because, hey, it's a switch. We'll use the default login credentials. We don't have to keep track of them because we know they're out there. And everybody on the inside of our network's a good guy, right? Not necessarily. So that one can be mitigated fairly easily. But a couple of other things you can do. Don't use those default VLANs. Use odd-numbered VLANs that other people you don't think are using. You can disable trunking. So if I have a switch that doesn't need to catch that VLAN, so it's on my, for example, on the server side, I don't need to do that. So I can drop that off. Change the password on all of your equipment. Support security methods. So not only like doors and locks, but if I have unused ports that are sitting out there in the public view or even in private view, secure them. So there's a couple of ways you can do that. I can disconnect them at a patch cable, so I have to reconnect them. I can turn it off in a switch that hopefully I've changed the password on so nobody else can get to. You can actually buy locks now for the RJ45 jacks that you can actually lock each port. So it'd take a little effort for somebody to get that out. They could probably do it with a pair of pliers and destroy the port. So there's ways to do that securely. So you can also specify specific VLANs on each trunk. And again, it's a little more configuration than just saying, hey, I want to auto trunk everything. Anything that's a VLAN, pass through. So how much security do we need? I'm going to argue that in this current environment, we need as much security as you can possibly find. It does take more setup. It is more inconvenient. So when I go add another computer to an office, now I have to repatch something or I have to reconfigure a switch. Is that 3 to 5 to 20 minutes? Is that worth it for security? I think it is. I think it is. So these are ways we segment our traffic. So we segment our traffic for a whole lot of reasons. Mostly we do it for performance and security. Performance used to be the major reason, and I'm going to think that at this point we're looking more at the security aspect. We're all on at least 1 gigabit per second networks. Our performance is probably decent. How do we secure that? Because the threat vectors out there are everywhere now. Whether it's I downloaded a screensaver and suddenly my computer's infected, to remote access hacks, to, hey, you have some information on this network I'd like to sell to somebody. And so we have people inside, whether they're malevolently selling something or they just don't realize when somebody calls and says, hey, if you go to support site blah blah blah, I can help you install this piece of software. Oh, coincidentally, I just got a piece of software in an email. Let me go in and do that. Now you've remote accessed somebody into your network. So I had a long time group of people or a client, and they have several employees. I had one call me the other day, and the person said, well, I need to remotely control a computer. And I said, well, we set you up, and in fact, I use Splashtop for them and set them up. So, well, I don't like it. It doesn't do what I want it to do. And I'm like, okay, what does it not do? And he couldn't really give me an answer. But he has a Windows 10 machine at home, and he thought he should be able to just connect his Windows 10 machine at home directly using Microsoft RDP, and I should open up the ports on the network to allow him to do that. And I had to rein him down and say, no, that's a bad idea for a whole lot of reasons. This is why we use this software. This is why the owner of your company said you're going to use this software. So you have to work out and look at those issues. And I don't think that necessarily he intended any specific harm, but opening up ports and opening up interfaces for no really good reason when we had a solution for him that quite frankly works better, and I'm not really sure what his motivation is other than you'll find out that there are some people who just don't like the recommended model. They want to do something different. Like they're, oh, I don't want to do this, I need to do X, Y, and Z model. And in this case, what he's opening up is a lot of access to systems potentially that could be compromised. And so I had to talk him off the ledge and tell him not to do that. And now the bad thing is for whatever reason, he's got some software that doesn't play nice, and so we've had to give them administrative access. So I actually run at that location, I run Spiceworks for them, or a version of Spiceworks in the inventory. So I'm going to watch and see what software he's going to try to install next, and then go bebop him on the head a little bit. Because I am sure that the next thing he will do is install TeamViewer. This is my guess, and I'll tell you guys probably in a week what he did. That, I'm going to install the free version of TeamViewer because it says it's free. Not for commercial use, but he says it's free. And so we'll see what reason there is there. So now, what he connects to, some of that is going to get searched for, and we already know that it gets hit pretty regularly because there's some PLC software in there. There's some automated equipment that's got an interface. So, all right. So, CIDR. You need to know what CIDR is. It's that classless interdomain routing. In other words, instead of just being class A, B, or C, I can slide that pointer anywhere. So I can make the network's subnets fit my needs. And again, depending on the number of VLANs, I typically, like I said, I will use at least 3 VLANs, and I will typically do the class A, B, and C addresses within each one. That way I can keep track of which one is pretty easily. So I tend to have all the data on the 10 range network just because that's my standard. But if I need more VLANs, then I need to start breaking them down and figure out what they are. And so it depends on the network. Subnet's great. Another way to divide a network up, we can combine the two. Subnets are useful when I can't use VLANs for whatever reason. Maybe they've decided not to buy switches that are capable of it. They're not willing to spend that kind of money. You can do it kind of the old-fashioned way. And then the last way is really completely isolating a network. So separate switches, bless you. Separate switches for each network, separate IP ranges for each network. I have even seen some places that go to the point of they have separate connections to an internet service provider, simply because they want to maintain that isolation that far apart. There's reasons, and sometimes it's not as secure as they think. So especially when they have a wireless router plugged in accidentally as a switch, that's kind of an issue. But I understand the paranoia, and it certainly does happen in some areas that they're very high-value targets. And you think your own computer isn't a high-value target, but it's interesting if you set up a VirtualBox machine and you have an unpatched Windows version sitting out there on the internet. Even on VirtualBox, you'll see you're being attacked pretty quickly, and you can actually check that and see. So set up a Windows Server version in there, let it sit out there unpatched on the internet, no antivirus, and you'll be compromised probably within about 2 days. It's pretty scary out there. So these are ways we break up that network and try to keep us from getting infected. All right, so this week was a little less work. So when I planned it out, and I wasn't really thinking about COVID, that we were going to do some hands-on stuff that I'm not sure how we're going to do still yet. So in your assignment link this week, I have made that Lab 8.1. I took it out of the link, and I just made it unavailable. I had a lot of people having issues trying to get into Cengage. Cengage has been truly interesting this week, and I was tempting to upload data from the weeks that it's not doing, Cengage being a pain already. And I ran into something kind of odd, and I'll have to see how I can do it. So in this class, there are some of you that have student IDs that begin with a 0. Well, that presents a little bit of a problem when I export, because what I do is I export down the gradebook out of Blackboard, and then I merge these two Excel files together, and then it uploads it. And well, it keys off of your student ID number, except it's listed as a number field. And what does Excel do with those zeros? It cuts them off, and then it says, nope, these addresses aren't valid. Well, if it just did that, and I just had to put 4 people's data across there, I could manually do that probably pretty easily. Except in the great tradition of Blackboard, instead of doing that, it just skips those columns or rows, squishes them up so people don't get the right values when I do that. So, working on a solution for that. I'm fairly certain I can come up with one. It just was one unanticipated in the other issue. So we've also got issues in a couple other classes where Cengage doesn't want to upload anything other than 100%. What we ran into, and they found a note somewhere buried in the developer's notes that, oh, that's not really a issue. It's a design feature. And what they're anticipating is that everybody gets 100 or something weird, and they will push up those when it hits the due date. Well, we don't typically put the due dates in the stuff in Cengage separately than we do the one in Blackboard. So it never hits a due date to push it uploaded. Well, the problem with that is once we did that, you would never be able to get back into it. So say I had it assigned on Sunday, I can't reset that due date very easily in Cengage. So if Chris was sick, broke his leg or something, said, hey, can I do that and turn it in on Monday? I don't have an easy way to do it on Monday. So interesting notes from the Cengage people. So if you want to sit on hold for a long time and not learn a whole lot, I can point you to a phone number or two. But so we will get those loaded up. I'm just may have to do a little more manual work than I intended to. So, and then to make my life even better, Windows decided to do an update on my primary computer in the upstairs in Auburn. So I went in there last night, and all of a sudden it's signing me into an online account. Not a big deal. I resorted back to the local account. I don't like Microsoft doing that, but whatever. And then it said, oh, you have some file system errors. On your next restart, we'll fix your file system errors. And I did.